Hi guys, so this video is going to cover the surface areas of cylinders and cones. This again is in addition to what's in your book, so there's no section that matches this, but we're eventually going to get into volumes of surface area, of cylinders and cones, so we'll pull it together. The good news is this is a lot shorter than prisms and pyramids, and if you understand prisms and pyramids, you understand cylinder and cones. It's just new formulas. So we're going to start with a cylinder. A cylinder's lateral area is 2 pi RL, where R is your radius and H is your height. So if I have a cylinder, which has a circle at the top, a circle at the bottom, okay, the radius can either be shown here or here, and then the height is your vertical length. So basically, a cylinder is like a prism that has a circle as its base. So if you remember the formula for a prism, it was perimeter times height. So if you think about perimeter of a circle is the same thing as circumference, and circumference is 2 pi r. So they're basically the same thing, except now we're taking that base and we're making it specific to a circle. So lateral area of a cylinder is 2 pi r. Total area is 2 pi r h, which is the same thing as 2b because there'd be two circles, and that 2 pi r h. You can also say 2 pi r squared, plus if you've already found it, the lateral area. And again, h is the height of the cylinder. So it's going to be straight up and down. On either side, those would be the same length, and that would be your height. So the only two pieces of information you need and can get for a cylinder are the radius and the height. The only variation on it, sometimes you'll see where they give you the diameter, and then you have to cut it in half to get to the radius. That's about it. Cylinders are pretty much the easiest one. Cones are like a pyramid with a circle as its base. So the lateral area for a cone is pi RL. If you remember, lateral area for a pyramid was 1/2 perimeter times slant height. And perimeter of a circle is 2 pi r. So if I did 1/2 times 2 pi r, I end up with just pi r. And then the L is there for the slant height. Total area is pi r squared plus pi RL. Again, if you compare it to a pyramid, it was base plus 1/2 perimeter times slant height. So that base is a circle, pi r squared, plus 1/2. Perimeter of the circle would be 2 pi r times the slant height, which simplifies to pi RL. So normally, if you're memorizing these formulas, I would say if you know the prism and the pyramid, you can derive the cone and the cylinder. The good news is that in the environment we're at right now, you're going to be taking these tests at home, and that means you're going to have the opportunity to have a note sheet with these formulas on them. So as we move through the chapter, I would say definitely keep a note sheet of all the different formulas. So here is your radius, and here's the slant height. The difference between cylinder and cones is that sometimes you'll be given the height, and you've got to find the slant height. And for those, you would do r squared plus h squared equals l squared, because that's a right triangle, and you can use the Pythagorean theorem. Okay, example 1 says use the diagram to find the following: the base area, the lateral area, the total area, and the volume. So the B is base area, and this is a circle, so it's pi r squared. R is 5, so it's pi times 5 squared, which would be 25 pi. And we'll keep these in terms of pi. Lateral area is 2 pi r h, which would be 2 pi 5 times the height, which is 7. So I can multiply this in any order. I can do 2 times 5 is 10, and 10 times 7 would be 70 pi. And actually, let's add the units on. So this would be centimeters squared, and this would be centimeters squared. Total area would be 2 pi r squared plus 2 pi r h, or 2 pi r squared plus the lateral area, since we already have that. So I'd get 2 pi 5 squared plus my lateral area, which is 70 pi. 2 times pi times 25 plus 70 pi, or 50 pi plus 70 pi, which is 120 centimeters squared. And the volume we'll get to, so don't worry about it for now. We'll get to that when we get into the notes for that section. All right, this last example is your cone. So this time it says use the figure to find the base area, the lateral area, the total area, and then we're going to skip again volume for a cone. So remember, for a cone, the base would be a circle. This would be pi r squared. If the whole diameter is 14, then the radius would be 7. So this would be pi times 7 squared, or 49 pi meters squared. The lateral area is pi r L. So it'd be pi times the radius, which is 7, times the slant height, which this time is given to you, is 12. And that's 84 pi meters squared. The total area is pi r squared plus pi rl, or pi r squared plus the lateral area. We already know pi r squared, that's 49 pi, plus the lateral area we also already know is 84 pi. And I get 133 meters squared. So the other variation of the cones that you'll see is sometimes you'll be given for example, you'll be given the slant height, or sorry, the regular height instead of the slant height, which you're going to need when we get to volume. But let's say that this was, let's say this is 4 and the entire diameter was 6. I could cut that in half to make it the 3 for my radius, and then I can use the triple 3, 4, 5 to make that. So that's how you could get your slant height. And if by chance, when they gave you those values, they weren't triple, so let's say it was 2 and it was 4, then you can just use their Pythagorean theorem to find that slant height. So a refresher on your triples that'll help you, it's 3, 4, 5, 6, 8, 10, 5, 12, 13, 8, 15, 17. Those are the most common ones. Obviously, there's more than that, but those are the ones that are probably the ones we've seen the most. All right, that's it. That wraps up the lesson for cylinders and cones. Like I said, it's pretty short. Please take the time to work on the assignment for this, which is, again, surface areas of cylinders and cones. And then we'll go over that homework when I Zoom with you guys next. Have a great day. Actually, have a great weekend, because I won't see you again. Have a happy Easter, and I will see you next Tuesday.